Theorem is going to tell you if a couple of side lengths can actually form a triangle. So for example, on your homework tonight, you have a super long hypotenuse and sides that are very, very tiny. Am I ever going to be able to get those sides to touch to be a triangle when that hypotenuse is that big? No. Okay? So what the triangle inequality theorem says, basically if you can actually form a triangle or not. Just because you have three sides doesn't mean you're going to get them to connect. So your triangle inequality, a triangle exists if the sum of the two smaller sides is longer than the third, which your third side is going to be your longest side. So as long as the sum of the shortest is bigger than the longest length alone, you're good. So just quickly, if I look at number 1, I have side lengths that are 8, 17, and 24. 24 is obviously my biggest length, right? So if I take my two smaller, 8 plus 17, and that comes out to be bigger than 24, it's going to form a triangle. So what is 8 plus 17? 25. So is 25 bigger than 24? So yes, this forms a triangle. Number 2, since there are two that are the same length, for this one it's fine because 7 is still your biggest. 3 plus 3 is 6, right? So is 6 bigger than 7? No, so this does not form a triangle. But the reason I wanted to talk about number 2 is because on your homework there's one where your side lengths are actually 7, 7, and I'm not sure, but I'm pretty positive it was 1. So your biggest side, these two are the same, right? Mm-hmm. It doesn't really matter. You just pick one of the 7s to be your biggest side. So that means your other two sides, 7 plus 1, are those still bigger than one of the 7s? Yes. So yes, that one would work out. And like I said, that's a question straight from your homework tonight, so I wanted to talk about it. Let's jump down a little bit to number 5. Number 5, just shout it out for me. Which one is your biggest length? 50. So is 28 plus 22 bigger than 50? What is 22 plus 28? 52. So is 50 actually bigger than 50? No, they're equal. And notice that your sign does not say greater than or equal to. It strictly has to be greater than. So since these are equal, this is a no. I want you guys to do 7 and 8 really quickly on your own. Don't shout out any answers, just do them. Make sure you show your inequality as work, please. Cassie, for number 7, what did you get is greater than 24? And then tell me if it was a yes or a no. So what was the sum?
33 or
23. So is that a yes or a no? No. Maeve, what about 8?
42.
And is that a yes or a no?
Yes.
Good. All right. Any questions on those two? Okay, so one thing that the EOC likes to play around with, not every year, but I have seen it in the past, is if they give you two sides, they want, kind of if I look at 15 and 16, they want you to be able to determine if a certain length would form a triangle or not. So here's a quick and easy way of how to figure that out. So when you have two side lengths, you don't know if these are the short sides, if the 22 is going to be the longest. Plus, as long as your two short sides add up to be bigger, the triangle works. So there's many lengths that can come together to form a triangle. So if you want to find the range of values that third side can be, a really good way of doing this is, if you subtract your two sides, that's going to be the lowest side length a triangle can be. And then if you add your two sides, that's going to be the biggest side length that you could have that would still form a triangle. So for example, if I go back to number 9, what is 22 minus 14?
8.
8. So that's going to be the smallest side length that's still going to be able to form a triangle. Then, if I add 22 plus 14, what is 22 plus 14? So that's going to be the biggest length of a triangle that I can get, and it would still form a triangle. So anything in between those two numbers would work. So if I gave you a side length of 20, is it going to work?
Yes.
What about 50? No, because it's too big. What about exactly 36?
No.
Okay, basically anything that's in between. That'll do. What about number 10? What is the smallest side length a side could be, and it could still form a triangle here? 3, because 31 minus 28 is 3. And what is the biggest side length going to be? 59. So where these questions kind of make sense, where you would do this, look more like 15 and 16. Given the two side lengths, check all the possible lengths that could form a third side. So yes, they give you 15 and 27, but you just want to check the ones that'll work. So this is where you need to know this little inequality of the biggest and the smallest. So 15 and 27, what's the smallest length you could have there? 12. What about the biggest length you could have? So raise your hand if you can tell me all the boxes that you would check on number 15 that fall within that range of numbers here. Don't shout it out. Just tell me the numbers here. Darren? A, C, D. So 34, 29, and 18. Very good. What about 16? Raise your hand if you can tell me the inequality piece. The difference in the sum. The smallest and the biggest. Liza?
36 and 54.
Good. So then, Liza, what boxes would you check?
47 and 39.
Good. And notice how Liza did not say 54 because your value strictly has to be less than 54. Okay? So it's not allowed to be equal to. All right. Moving on. I have told you in the past that your angle measurements and your sides have a relationship with each other. So if I have 3 side lengths labeled from biggest to smallest, that can tell me what angles are going to be from biggest to smallest without even knowing what the angles actually are. So for example, 7 feet, that side length has a relationship with angle A. Then my 10 feet has a relationship with angle C. And 13 feet has a relationship with angle B. So I use the colors there to kind of help you. Opposite angle, opposite side. So if your smallest angle is always going to be across from your smallest side. And your largest angle is always going to be opposite of your largest side. Again, without having to know what the angle measurements actually are. So if I look at my picture here, I have 7, 10, and 13. Obviously, smallest to biggest, least to greatest, would be 7, 10, 13. But what order would the angles go? Raise your hand. What order would the angles be? Marissa, I'm sorry.
A, C, B.
Good. So again, you're just looking at what comes across from it. So 7 was the smallest, across from that is A. Then my middle one was 10, across from that is C. My largest is 13, across from that is B. And it works both ways. So now if I do know, actually, sorry, I was getting a little ahead of myself. Why don't you guys do 17, 18, 19, and 20? But notice how there's a change in directions. 17 and 18 are least to greatest, where 19 and 20 are greatest to least. But do all 4 of those real quickly on your own. Make sure since they're angles, you put the little angle symbol in front of them. I busted some of you guys for that on your quiz. Yeah, I plan to do that tomorrow since all we're doing tomorrow is a study guide.
Are there grades in the grade book for that?
No.
Oh,
All 4 of them. All right, I want a different person for all 4 of these. So a volunteer for number 17, please. Remember, these are least to greatest. Cassie?
MPN.
MPN. And again, make sure you have your angles on there. 18. Jackson? TRS. 19 is a greatest to least. So now we're going biggest to smallest. Jaden? CBD. And 20. Jana?
XYW.
Good. All right. Any questions on those? Pretty easy, right? Just follow your diagonals. So it works the opposite way with your sides. If you know your angle measurements, then across from your angles, I'll draw the different colors again. So 42 is across from, the only issue with sides is you need to use 2 letters instead of 1. So 42 is across from DF. And then 103 is across from EF. Now, if I am missing a third angle, how could I very quickly find that third angle? Can someone do that for me real fast?
35.
35. So now that I know all 3, hopefully I can tell the least to greatest, and across from the 35 would be DE. Or ED, the order of the letters doesn't matter, so don't worry about which one comes first. So across from the smallest side is your smallest angle. And across from your largest side is your So if I'm looking at the picture that we're using from the example and going from least to greatest, raise your hand if you can tell me my smallest side to my shortest side. And remember, with sides, we have to use 2 letters as if they're segments, because they kind of are segments, right? Liza, what do you think?
ED to DF and then EF.
Good? And like I said, on my key, I actually had like DE. The order of the letters doesn't matter as long as they're the same 2 letters. Okay. On your own, I want you to do 21 through 24. Remember, read your directions. One says least to greatest, the other says greatest to least. And you're just following your diagonals. 31 goes to KL. 57 goes to JK. And you'll have to do some subtraction there to find whatever K is. But across from K is JL. But do all 4 of those on your own. I like your shirt thing. Flannel.
Thanks.
How do we find what that third angle is again that's missing? Subtract from 180. Do we need more time? Thumbs up if you're ready. Okay, for 21, since I already have the colors labeled for you, if we subtract from 180, we get 92 for angle K. So that means least to greatest for your angles is J to L to K. So across from J is KL, across from L is JK, and across from K is JL. Again, if you have the letters flip-flopped, as long as they're the same 2 letters, you are good to go. Who can tell me, for 22, you need to tell me the missing angle and the 3 segments. Marissa?
59, and then ST, SVTV.
Good. And 23, same thing. Tell me the missing angle. And then now we're going from greatest to least. Olivia?
44, and then XZ, YZ, and then XY.
Good. Last one, 24. Last one for this page. Cassie?
46,
All right.
BE, DB.
Oops. BD you said? Or DB, whatever.
DE.
In DE? Perfect. Thank you. All right, real quickly, one last thing is using the same rule that we were just talking about. If you have a small angle, you're going to have a small side across from it. You can use that rule to compare to triangles. So it's called the hinge theorem. I'm not going to make you learn that. I don't even know theorem names. I just learn what the rule is and apply it. But what it says is if 2 sides of a triangle are congruent to 2 sides of another. So look at this picture. 2 sides are congruent to 2 sides. Then the included angle, included means where your 2 congruent sides meet, of the first triangle if it's larger. So if this one is larger, I'm going to put big. Then this one, I'm going to put SM for smaller, so that way you know which is which. then that means that their opposite side, BC, is obviously going to be bigger than EF. So like I said, it's kind of like common sense based off of the last set of rules that we were just practicing. Like if A is a 92-degree angle, and that would be a bigger side, then if this were a 50-degree angle, this would obviously be smaller than this one. Okay? So that's all the theorem says. So if angle A is bigger than angle D, then what that means is side BC is going to be bigger than side EF. So write that down, please. And then obviously the converse of that is the exact same thing, but instead of starting with the angles, you're starting with the sides. So if BC is bigger than EF, so again, if this side is bigger than this side, then that means angle A is going to be a bigger angle than angle D. You don't know what those angles are. You just know in comparison to each other, one's bigger or one's smaller. Okay? So no exact numbers, just comparing the difference between the two. So for number 1, if I look here and I am comparing KL, which it's important to even know what side you're comparing here, to PM, you want to look at the angle that's across from that side. So I'm looking at 79 and I'm looking at 74. Which one is going to be the bigger one? KL, because it's bigger, 79 is bigger than 74. So if I want to compare the sides and angles by filling in the blank with a less than or greater than symbol, use your open mouth situation. The bigger side is KL, so KL gets the bigger mouth. That would be a greater than symbol. Remember, greater than looks backwards, but less than looks like an L, a squished L, just turned sideways. But I like to use the mouth thing, okay? So number 2 is just a little bit more work on your end. If I look at the two sides I'm comparing here, I have AD, which yes, that's across from 59. And I have BC across from 65. Just kidding, this one's not more work. Got ahead of myself, 3 and 4 are more work, sorry. Which one is my bigger side? BC, because it's across from a bigger angle, which is 65. So BC gets my open mouth. Common sense, right? Okay, so now, we have a little bit of extra work on 3 and 4. So WX is across from 53, but XY is across from this angle that I don't know. But do I have enough information to figure out what it is?
For sure.
What would I do, Jana?
180 minus 93 minus 32.
Do you know what it is?
55.
55. So now that I know this angle's 55, is WX or XY bigger? Because it's across from 55, the other was 53, so across from 55 is XY. Can you guys do number 4 through the rest? Let's do 4, 5, 6, 7, and 8 on your own. quickly here, I am going to make you learn the names of less than and greater than. Remember, if you have your L and you turn it sideways, that's your less than. If it's the other way, it's greater than. So if it looks like an L, it's less than. The other one by default is greater than. So for number 4, raise your hand if you can tell me the missing angle that you needed and if it's less than or greater than. Jaden.
97, and it's greater than.
Perfect. Number 5. Number 5, you didn't need a missing angle. You just need to tell me if it's less than or greater than. Go ahead, Cassie.
Angle D is greater than.
Perfect. Number 6. Darren. Less than. Number 7. Maeve. Less than. And number 8. Sabo.
Less than.
Less than. Good. Any questions on those?